Good day to you, doctor. My name is Sakinah Binti Supahat. My metric number is 243-04-678. My group is T2C. My lab partner is Nurul Hazimah Binti Hardiri. In my point of view, objective for part A is steel ball were fired at a various angle 25, 35, 45, 55 and 65. For part B, projection angle was fixed at 45 degree while initial speed varied across the tension stage to observe the effect on maximum range. In question A, for me, the best angle of projection to start with, especially to observe the most balance of projectile motion, is 45 degree. Both the theory and experimental data, the maximum range is reached at projection angle exactly at 45 degree for every initial velocity. Starting at this optimal angle, it allows to establish a baseline for the maximum possible horizontal distance before testing at smaller or larger angle. In question B, to accurately measure maximum height of steel ball, we need to clamp a meter scale vertically in a barrel base and move it parallel to plane of the ball projection. The height can be determined by watching the peak of trajectory against vertical scale, and it can also determined by using the theoretical formula to cross-verify visual measurement with initial speed. For question C, in my point of view, is the time taken to reach maximum height is actually can be determined using the kinematic equation for vertical motion that provided in theory. Vy equals to v sin theta minus gt. Vy is 0. In experimental, actual initial speed was calculated in data analysis and the acceleration due to gravity to solve for this time. T height will be exactly half of the total time of flight if the projectile lands at the same height from which it was launched. In question D, theoretically, the material of the ball not affect its trajectory. The equation for range and maximum height not contain a variable for mass. They depend on initial velocity, projection angle, and also gravity. The law of kinematic, absence of air resistance, all objects fall at the same rate of acceleration due to gravity 9.81 meter per second squared, regardless of their mass or composition. Question E, in a real laboratory environment, air resistance is a significant external force that acts against motion of the ball. Effect of density and inertia, a steel ball will provide accurate result compared to wooden ball. It is better at resisting the decelerating effect of air drag. Moreover, for two balls of the same size, the air resistance force is roughly the same. However, since F is equals to ma, the lighter wooden ball experience much higher deceleration. It causes to lose speed more quickly, so it becomes shorter range and lower height than the theoretical prediction. Thank you.